The entire Asian economy is suspended over the ocean. Every financial trade, every video call, and every piece of critical data travels through physical cables laid directly across the seabed. Down in the dark, these data pipelines are surprisingly fragile. A line resting on the ocean floor, no thicker than a garden hose, carries enough bandwidth that a single snap could freeze international supply chains. In many Western countries, data struggles through a maze of decaying copper grids and tangled telephone poles. In Singapore, that same data flows with almost zero friction. The common explanation for this speed is size. Most people assume that wiring an island smaller than New York City is a simple administrative task. Geography is a deceptive metric. These tight borders actually create a pressure cooker for engineering, forcing solutions that larger nations can afford to ignore. The first obstacle is density. Pushing a digital signal horizontally across a flat suburb is straightforward, but Singapore is a forest of concrete towers, a brutal physical barrier for data transmission. Engineers call this vertical latency. As a gigabit connection travels 50 stories up reinforced concrete, the signal degrades. Add immense tropical heat baking the conduits and electromagnetic noise from overlapping Wi-Fi networks fighting for the same spectrum. To beat that degradation, a pristine signal must be shoved up thousands of shafts across the city with no margin for error. Maintaining zero latency in a dense concrete jungle requires a constant physical confrontation with the laws of attenuation. This local density is the final step of a much larger journey. Before data can shoot up a skyscraper, it has to reach the island from across the globe. This map tracks global data flow across the ocean. Over 30 major submarine cables detour directly into the geographic coordinates of Singapore. This concentration creates an extreme geographic choke point. All these lines terminate at restricted, densely packed landing stations in Tuas and Changi. Inside those conduits are microscopic strands of glass, carrying the financial transactions and military communications of dozens of surrounding nations simultaneously. The island operates as the unbypassable transit hub for regional traffic. It is the Changi airport of the internet, routing the most critical data of the continent through its basement. Managing that volume of data required a massive underground distribution network, a blank canvas of dark fiber buried beneath every street. In the late 2000s, the OpenNet project began. The government tore open the asphalt across the city to lay a universal grid from scratch. In most countries, the company that lays the physical wire owns it. This creates regional monopolies that typically keep speeds low to maximize corporate profits. Singapore dismantled that model with a 3-layer structural separation. One entity, the NetCo, manages the dark fiber. A second entity, the OpCo, manages the active light signals, and the retailers sell to consumers. By law, no single company can control all 3 layers. Forcing private giants to share the same passive fiber network shattered the monopolies and drove consumer prices down. This speed is a triumph of top-down policy that prioritized infrastructure sharing over corporate gridlock. The raw capacity of this network goes far beyond what any household needs for streaming video. They are currently deploying a symmetric 10 gigabit network and upgrading to quantum-safe encryption standards island-wide. This is a ghost network. It is built for data volumes that modern consumer hardware cannot process, specifically targeting the requirements of high-frequency trading and generative AI compute clusters. For a nation with no natural resources, data throughput has been engineered into a primary, lucrative commodity. These investments move the network out of the realm of public utility and into the architecture of national defense. Because Singapore hosts the fastest and most secure pipelines in the hemisphere, neighboring powers find it nearly impossible to bypass this hub. The cost of the resulting latency would effectively handicap their own markets. When your neighbor's economic prosperity is physically routed through your basement, your infrastructure becomes a primary lever of sovereignty. Beneath the concrete, they have constructed an invisible fortress, securing their